To analyze the data to test the hypothesis using the multiple linear regression analysis, let's enlarge the SPSS script. To analyze the data, select Analyze, Regression, and Linear. Select the dependent variable creativity and click the arrow button to move it into the dependent box. Then highlight the 4 independent variables and click the arrow button to move them into the independence box. Click the Statistic button, select Modified, Descriptive, and Collinearity Diagnostic. Then click the Continue button. Click the Plot button, then select ZRESID, which is the Standardized Residual Score of Creativity, and move it into the Y box. Then select the ZPID, which is the Standardized Predicted Score of Creativity, and move it into the X box. Then click Histogram and Normal Probability Plot under the Standardized Residual Plot. Click the Continue button and click the OK button to get the result of the analysis. The result of the multiple linear regression analysis are presented in tables and graphs. The tables are descriptive statistic, correlation, variable enter, remove, model summary, ANOVA, coefficients, collinearity diagnostic, and residual statistic. Besides that, we have the standardized residual plot for histogram, normal PP plot, and a scatter plot. Let me elaborate them one by one. In reporting the results of analysis, we will first check whether the data meet the assumption of multiple linear regression analysis. Then, report the result of hypothesis testing. The first table, descriptive statistic, presents the mean and standard deviation score of the 5 variables. As you can see, the mean score are ranging from fluency with 51.19 to originality with 71.05. The data of the 5 variables are in score, which are continuous data. Thus, the data meet the first assumption of the multiple linear regression test for continuous scale data. The second assumption of the multiple linear regression analysis is the dependent variable and the independent variable are highly associated. The second assumption is made if the correlation values between creativity and the 4 independent variables are larger than 0.30. In the correlation tables, the Pearson correlation coefficients are from 0.455 for fluency to 0.830 for originality. And all the correlations are significant with p less than 0.05. This means the data meet the second assumption of the test. The correlations table also presents the intercorrelation among the 4 independent variables. The table shows that intercorrelation coefficient between the 4 independent variables are ranged from 0.155 to 0.691, which are smaller than the benchmark of 0.70. The correlation between the independent variables are not strong enough. Thus, they are expected to be independent from each other. This indicates that the data might meet the assumption 3 for multi-collinearity. To check whether the data is free of multi-collinearity problems, we move to the coefficient table. At the right end of the table, it presented the collinearity statistic result. The data has no multi-collinearity problem or achieved the assumption 3 when the tolerance value is larger than 0.20 and the VIF value is smaller than 5.0. The results show that the tolerance value of the 4 independent variables are larger than 0.20, which is range from 0.433 to 0.801, and their VIF values are smaller than 5.0, range from 1.249 to 2.310. This means the independent variables are independent from each other and the data meet the third assumption for multi-collinearity. We move to the fourth assumption, which is normality. We will evaluate normality of the data with the histogram and normal PP plot. As can be seen, the histogram of regression standardized residuals for creativity is distributed normally. Most of the values are distributed at the middle of the histogram. Then we move to the normal PP plot. The normal PP plot of regression standardized residuals for creativity is distributed closely to the normal distribution line. Although some of the scores slightly deviate from the line, it shows good fit of the data to the normal distribution line of the plot. No major deviation from normality in this plot. We conclude that the data is normally distributed and it meets the fourth assumption normality. Then we move to the residual statistic table, where we will check the assumption 5, which is homoscedasticity. The standardized predicted value range from negative 1.456 to 1.796, and the standardized residuals range from negative 1.803 to 2.328, are in the homoscedasticity range of negative 3.3 and positive 3.3. Hence, the data meet the fifth assumption of homoscedasticity. The result of this table is also presented in the scatter plot. It can be seen the data are distributed in the rectangular shape, with most of the score of creativity are distributed fairly across all the value of the four independent variables in the range of negative 3.3 and positive 3.3. This confirms that the data meet the fifth assumption of homoscedasticity. The fifth assumption can also be evaluated through the scatter plot by drawing the reference lines at the x-axis and y-axis. To do this, double-click the scatter plot to open the chart editor. Click the Add the reference line to the x-axis button. The data of the standardized predicted value of creativity are distributed equally across the left and the right side. It shows linearity of the correlation between creativity and its four independent variables. To draw a reference line at the y-axis, click the Add the reference line to the x-axis button. In the position box, change the value 0.05 to 0.00. Then click the Close button to close the chart editor. Note that the data of the standardized residual value of creativity are distributed equally across the four scatter plot sections. This indicates linear relationship between creativity and its four independent variables. This means the data meet the sixth assumption, which is linearity. After ensuring that the data meet the assumptions, we will report the result of the multiple linear regression analysis for hypothesis testing.